Alright, welcome to day 201. I'm doing a graph here. We have to do a hard, which I'm probably not going to be able to solve, but we'll keep it going, I guess. So we got build a matrix with conditions. You are given a positive k integer k. You're also given a 2D integer with row conditions of size n. Okay, and 2D integer array of call conditions of size m, where call conditions of I is left, right, above, below. Okay. The two arrays contain integers from 1 through k. You exactly have to build a k by k matrix that contains each of the numbers from 1 through k exactly once. The remaining cells should have 0. The matrix should also satisfy the following conditions. The number above should appear in a row that is strictly above the row at which the number below appears for I from 0 to n minus 1. The number left I should appear in a column that is strictly left of the column at which the number right appears for all I to 0. Return any matrix that satisfies the condition. If no answer exists, return an empty matrix. This is just pain right here, bruh. The diagram above shows a valid example of a matrix that satisfies all the conditions. Okay. Well, the conditions is above, below, 1, 2. So 1 has to be above 2, and 3 have to be above 3 have to be above 2, and then 2 has to be to the left of 1, and 3 has to be to the right of left of 2. Okay. If I were to visualize this real quick. I see now. Okay. So the conditions were 1 has to be above 2, that's true, and 3 has to be above 1. Okay. And column conditions, 2 has to be to the left of 1, right? So it is. And 3 has to be to the left of 2, so that's why it's here, and that's why we return this. Okay, I understand what to do, but how the hell do you solve this? Oh my goodness. Graph? How is this a graph problem? I have no idea. Well, okay, if we treat every condition like it's some graph here, right? Right, we have the row graph, which we can say is like this, right? We say 1 goes to 2, 3 goes to 2, right? And we also have our call conditions, or right, our column graph. What happens? Do we see any patterns? We see anything here, right? 2 to 1, 3 to 2, right? Is this useful to us? I actually want to draw this out instead, right? So if we have our matrix here, or graph here, what if we treat this as a directed graph, right? Let's say 1 goes to 2, so we'll say 1 goes to 2, and then 3 goes to, right? So, and then we'll say 3 goes to 2, right? Is this useful for us? Does this provide any utility? That's the row graph. Now the column graph, 2 to 1, right? So we'll say 2 goes to 1. Right? And 3 goes to 2. Oh, wait. Okay. So this is our, right here is our row graph. This is our column graph. Do we see something interesting? Well, when we build out our matrix, can we well, okay. What we notice is 2 here is being pointed quite frequently. Well, actually, I wrote this wrong. 2 goes to 1. So I don't know. I can't think of anything. I know. Let's see. What was the hidden sense? Can you think of this in terms of graph? I don't know. What algorithms would you find the order in nodes in a graph? Ooh. Well, okay, I'm trying to think of it in terms of a graph. What algorithm is there? Topological sort? Are you serious, bro? Alright. I don't know topological sort, so. Topological sort. Is this a topological sort problem? Oh my god. I need to know. That's so stupid. How to perform topological sort. Get some theory in, guys.
The first step is going to be to pick an unvisited node. I'm going to pick node H arbitrarily. Now we do a depth first search outwards from H in all possible directions, exploring where we can. Let's go to node J. Now that I'm at node J, I'm going to keep exploring. And so let's go to M. Now that we're at M, there's nowhere left to go, so we backtrack and add M as the last element to the topological ordering. Still at J, we still...
Let me see, topological sort boilerplate. I don't know any of the theory, so like this is like no point in trying, to be honest. Python. So what is the... Or I guess AI can give it to me. So we have to do... It's DFS. Okay. Why is this repeated? 2 has to be at the top of 3. Yeah, guys, I might have to take the L early on this one because I have zero idea how to solve this. So how does topological... Let me see this. How does topological sort? God. Oh my God. What if we consider only row conditions and for a second forget call conditions? Okay. Like imagine we have a k by 1, so all we need to do is place numbers correctly according in the row conditions. Let's say somehow we created this matrix. Okay, good. Now we know which row which will go. 1, 2, and 3, 2. So 1 has to be above 2 and 3 has to be above 2. For this example, we can build a so we know each row. But what about columns? Columns will also be sorted. 2 must, let's say 1 goes to 2. That means 1 must be less than 2, left of 2. So 2 has to be at the left of 1, and 3 has to be at the left of. Now that we have the correct node order, oh, yeah, either it can be this way where 1 is, yeah, and then this way. It's the only way for it to satisfy that. So now we have correct orders for both rows and columns, but we know for sure which let's say we now have correct orders for both rows and columns. We know for this for sure in which row element must be and in which column. We easily construct a matrix, sure. Let's say rows and columns sorting we obtained are just 1D arrays, which means that 1 is at index 0 and our okay. Oh my goodness, hold on. That's not that bad. we sort this, right? So like, okay, this is the we always start with the row, which number it is gonna be 1. Where is it in the column? We go look to this. Oh. Oh my god. The sequence created above is just one of the possible sorting. Topological sort isn't unique, which means that there can be multiple answers for one. Okay. So write DFS, right? My god. That's a lot of code. So we write some DFS, right? And then do topological sort, which is graph, source, destination. Yep. Okay. If not, then DFS. Nope. Okay. We will have res reverse, so we need to reverse it once more. Do topo sort on row conditions, topo sort on call conditions. I guess check for if we couldn't find if there's a cycle, return empty array, right? Then he did the sorting. No, not the sorting. Just like putting it in the right thing. Okay, why is he being such a hard read? Saw this code in NeCode.io's YouTube channel. That is kind of a nice solution. Okay, I actually understand it now. But I still don't get topological sort. Like, I need to do some topological sort practice. So what it did was topological sort on the rows, topological sort on the conditions. I guess put those resultings together, and it will, like, we know where 1 and 1 will go because we know that 1 will be in row 0, and the column will tell it where in the column and stuff. So guys, I don't know what to do anymore. Let's see. We could do BFS. Jeez. So yeah, you have to determine ordering and stuff. Alright, I'll try, I guess. But honestly, I have to copy the solution because I can't really. It's a pretty difficult. I need to like self-teaching myself. Right? Oh my god. Where's that guy's solution? So it wrote DFS, right? Okay, I see. Def DFS source will have the graph visited, curve, path, and res, right? If source in curve path return false. If source in visited return true. Visited dot add source cur path dot add source. For every n in graph with the source, if not DFS, and graph visited cur path res return false. Path dot remove source res dot append and return true. And then do the topo sort. Def top sort edges. So graph is a default dictionary. Every source in edges graph source dot append destination v is a set, curve path is a set, res is a list. For every source in range of 1 to k plus 1. Okay, why is putting an extra 1? That doesn't make sense. Why do we add an incrementer? If not DFS source graph visited cur path res return empty list, return the reverse of the list. So you do DFS, but it's just DFS, but it's DFS, but you just, the resulting of DFS but flip the order? Is that really what it is? Damn. If that's the case, then low-key, I might come back to this solution. Alright, I might come back to this problem. Top sort row conditions. Sort C sort. Then he does the value position. So okay, now that's a weird syntax. This is what I don't really get. What is this really doing? For every n, it's just doing a 0 to 0 for n in range from 1 to k plus 1. For every index and value in a new or sort v val Okay, I see what they're doing. Value position, this is your index. Do the same thing for column. Value and then 0. I see. I see. It does a topological sort, right? And then puts it in its right place. Yeah. Where's visitor? Visited. Okay. Why can I not copy code? Holy shit. For source in range of 1 through k plus 1. What is adding this do? It's just, does it not by default go to like increment by 1? Why is he adding that? I don't think that makes a difference. Yeah, it's not gonna make a difference. It's probably this. Index v. Oh, that makes sense. We should have put 1 here. Nice. All right. I know it was kind of a cheating day, but don't know much. I need to understand the graph topics more. So, but anyways, thanks for watching. I'll see you tomorrow. Peace.